Hello students, after having gone through the fundamentals of this chapter, which is surface areas and volumes, here in this lecture session we will solve all the problems given in the first exercise. As I've already told you that this chapter is very important, especially for those students who want to pursue their career in the field of civil engineering and in the field of architecture. So let's move on with the first problem. The first problem states that two cubes, each of volume 64 centimeter cube, are joined end to end. So find the surface area of the resulting cuboid. So there is one cube, right? And on top of that there is another cube. And the volume of one of the cube is 64 centimeter cube. So therefore this is x. So we know that the volume is x cubed. So we know that 4 into 4 into 4 gives me 64. So what is x? X is 4 centimeters. So one of the sides of the cube is 4. So now after having known that, what do? So we need to find the surface area. Now there are 6 sides, but if one cube is placed on top of the other, 2 sides are not revealed, isn't it? So suppose if I have another cube which is placed on top of it, we will not be calculating the surface area of 2 sides. And a cube, so if I am placing actually 2 cubes, one on top of the other, I need to calculate the surface area of 10 sides. Alright, so therefore the surface area of one of the side happens to be, the surface area of one of the side is 4 into 4, which is 16. So now I need to find the surface area of 12 sides, because the surface area of 2 sides, so we need to find the surface area of 10 sides, right? Because we are placing the cube one on top of the other, so we need not calculate the surface area of 2 sides. So therefore the area of 10 sides, so it's going to be 16 into 10, which is 160 centimeters square. So this is a very simple problem. So let's move on with the next one. A vessel is in the form of a hollow hemisphere which is mounted by a hollow cylinder. So you have a hollow hemisphere, and then this hemisphere is mounted on a cylinder. So this is a cylinder here. The diameter of the hemisphere is 14, whereas the height of the vessel is 13 centimeters. So the diameter is 14 centimeters. So if this is 14, what about the radius? The radius is 7. And this length also is 7, because this happens to be the radius. And the total length of the vessel is 13 centimeters. So what about the height of the cylinder? The height of the cylinder is 13 minus 7, which gives us a value of 6 centimeters. So we need to find the total surface area. So therefore the inner surface area, so I'll write SA for surface area of the vessel, is nothing but the curved surface area of cylinder plus the curved surface area of hemisphere. So I'll write HS for hemisphere. So we know the formula, isn't it? So the curved surface area of the cylinder is 2 pi into r. R happens to be the radius, which is 7, into h. H is the height, which is 6, plus the surface area of the hemisphere is 2 pi r square. So I can take 2 pi r common, so I get h plus r. So I get 2 into pi is 22 by 7, into r is again 7, the radius, into h is 6 plus r is 7. So 7 gets cancelled, so this is 13 into 2 into 22, so we get 572 centimeters square. A very simple problem. Problem 3 states that a toy is in the form of a cone of radius 3.5 centimeters, which is mounted on a hemisphere of the same radius. The total height of the toy is 15.5 centimeters. Find the total surface area of the toy. So here the radius is 3.5 centimeters, which has been given, right? So on top you have a cone and down below there is a hemisphere, and therefore the radius happens to be 3.5. The radius of the hemisphere is also 3.5, and the total height of the toy is 15.5 centimeters. Alright, so now I need to find this distance, so this is r, which is 3.5. So the total height is 15.5 minus the radius. This also is the radius, isn't it? Because this is a hemisphere. Now what about this height if I call this as h? So h is 15.5 minus 3.5. So I'll get it as 12 centimeters. So that is h. And I need to find the value of L. So this forms a right angle triangle. So L square equals h square plus r square. So let us use the Pythagoras theorem. So L is nothing but root of h square. Now how much is h? That is 12 square plus 3.5 the whole square. So if I do the calculation, I will get this as 625 divided by 4 the whole square. So this is a square. 625 is a square. So the root is 25 by 2. So that is the value of L. So now let us try to find the curved surface area of cone. The curved surface area of cone, what is it? I hope you remember, that is pi into r into L. So pi is 22 by 7 into r is the radius, is 3.5. 3.5 can be written as 7 by 2 into L. What is L? L is 25 by 2. So I get the value as 13.7.5 centimeters. That is 137.5 centimeters. And what is the curved surface area of the hemisphere? We know that it is 2 pi r square, which is 2 into 22 by 7 into the radius is 7 by 2 the whole square. So I get this as 77 centimeters square. So what is the total surface area? The total curved surface area is, I need to add these two. So the total curved surface area is 137.5 plus 77, which gives me a value of 214.5 centimeters square. So very simple problem. So now problem 4, there is a cubical block of side 7 centimeters. So there is a cube, a block. So the side is 7 centimeters. So this is 7 centimeters. Alright. A cubical block of side 7 centimeters is surmounted by a hemisphere. What is the largest diameter of the hemisphere which it can have? And what is the surface area of the soil? So now this distance is also 7. So I can have a hemisphere. So there's actually a square on top. I can actually have a hemisphere having a diameter of length 7. So the radius would be 7 by 2. So this radius r would be 7 by 2 centimeters. Okay. So this happens to be the largest radius value. Okay. So we need to find the largest diameter of the hemisphere. Of course, the largest diameter happens to be 7 centimeters. So now I need to find the surface area. So what is the surface area? Find the surface area of the entire cube, which is going to be 6 into 7 square. And then I add the surface area of the hemisphere, which is going to be 2 pi r square. And from that I have to subtract the surface area of the base of the hemisphere. Okay, because the hemisphere is sitting on the cuboid and I need to subtract the base area of the hemisphere. So this cubical block, the total surface area is given by the surface area of cube plus curved surface area of hemisphere. So I'll write HS for hemisphere minus the area of base of hemisphere. So this is actually a circle of area pi r square, where r happens to be 7 by 2. So now let's find out the surface area of the cube is of course 6 into 7 square plus what is the curved surface area of the hemisphere? It is nothing but 2 into pi, which is 22 by 7 into r square. See, the formula is here, 2 pi r square. R is 7 by 2 whole square minus area of the base, which is pi r square. So it is 22 by 7 into 7 by 2 the whole square. So this is actually 2 pi r square minus pi r square. This is pi r square, which gives me the area, the surface area of the cube plus pi r square itself. So if I calculate the value, we get the total value as 294 plus 38.5, which gives me a value of 332.5 centimeter square. So very simple problem. Problem 5. A hemisphere depression is cut out from one of the face of the cubical wooden block. So I have a cubical wooden block. So this is a wooden block which is present here. And what is done? So if this happens to be the base of the hemisphere, so I have a hemisphere here, and this portion has been cut out such that the diameter of the hemisphere is L. So of course the diameter is L, and this is equal to the length of the block, one of the sides of the block. So find the surface area of the remaining solid. So now what is the total surface area? Of course I need to find the surface area of the cube. So therefore that is the surface area of cube. And what is the surface area of the cube? Surface area of one side is L square, so it's going to be 6L square. And then I also need to add the surface area of the hemisphere, which is surface area, the curved surface area of hemisphere, which is pi into 2 into r square. So it's going to be 2 pi into r square. Now the radius is L by 2 because the diameter is L, so therefore the radius is L by 2. So we know that the curved surface area of the hemisphere is 2 pi r square, so it's going to be 2 pi into L by 2 the whole square, minus, I need to subtract the area of the base of the hemisphere. So what is area of the base of the hemisphere? Minus area of base of hemisphere. So this is very similar to the previous problem what we did. So area of the base is pi r square. So it's going to be pi into r is again L by 2 square. Okay, so I get 6L square. So this is 2 pi r square minus pi r square, so which is plus pi L by 2 square. So therefore this is nothing but equal to, if I take L square outside and if I take 4 also outside, so I get, so if I take L square by 4 outside, I get pi plus, so since I've taken 4 outside here, I need to multiply this by 4, I get 24. So this is going to be in square units, right? Because the unit of the length has not been given, so it is in general square units. So very easy problem. So next, problem 6. A medicine capsule has a shape of a cylinder with 2 hemispheres stuck on either side. So this is a capsule. So a capsule looks like this. You have a cylinder and then you have one hemisphere on this side, the other hemisphere on the other side. So this is a capsule here. The length of the entire capsule is 14 millimeters. So the entire length is 14 millimeter. Alright. And the diameter of the capsule is 5 millimeters. So this distance is 5. So we need to find the total surface area. So now this happens to be the diameter. So what is the radius? The radius is 5 by millimeter. So again here the radius is 5 by 2, or it is 2.5. So what about the length here? So the length here is, so this is 2.5, this is 2.5. So it's 14 minus 2.5 plus 2.5. So it's 14 minus 5, which gives me 9 millimeters. So the length of the cylinder is 9 millimeters. The radius of the cylinder is 5 by 2 millimeters or 2.5 millimeters. So now let's find out the total curved surface area. So therefore here the total surface area is nothing but, so this is one hemisphere, this is one hemisphere, 2 into curved surface area of hemisphere plus curved surface area of cylinder. So I have 2 into 2 pi r square plus, what is the curved surface area of the cylinder? The formula, it's 2 pi rh. So you have 4 into pi is 22 by 7 into the radius is nothing but 5 by 2 the whole square plus 2 into pi, which is 22 by 7 into radius is 5 by 2 into what about h? That is the height or the length. So let me call this as h here. Okay. So this is nothing but 9. So now, if I do the calculations, what do I get? 78.57 plus 141.42. So we get an approximate value of 220 millimeter square. So very simple problem. So here you have a capsule. So in between this is cylinder and this happens to be the height. Okay, which is 9, and then you have two hemispheres here. So curved surface area of one hemisphere plus one hemisphere plus the curved surface area of a cylinder will give you the total surface area of this medicinal capsule. So problem 7, a tent in the shape of a cylinder is surmounted on, if the height and the diameter of the cylinder are 2.1 meters and 4 meters, the slant height is 2.8 meters, find the area used for the tent, and also if the rate is 500 per meter square, what is the total cost? Of course the base area is not covered with the canvas. So this is a tent. So this is, of course, looks like a cylinder. So this is in the shape of a cylinder, and top of it we have a cone, right? So what is being given? So the cylinder height and the diameter is 2.1. So the height is 2.1 meters. So this is h, and the diameter is 4 meters. Okay, so therefore the radius is 2 meters. Since the diameter is 4, the radius is 2. And then on top is the cone. So of course the radius of the cone also will be 2. This also will be 2 meters. And the slant height given is 2.8. So this is slant height, which is 2.8 meters. So I need to find the curved surface area of the cone as well as of the cylinder. So the total surface area is the curved surface area of the cone plus the curved surface area of cylinder. So the curved surface area of the cone is given by pi RL plus 2 pi RH. This is the curved surface area of the cylinder. So pi is 22 by 7 into radius. Radius of course is 2, isn't it? So that's going to be 2 into L. L is the slant height, which is 2.8 plus 2 into 22 by 7 into the radius is 2 into what about the height? Height is 2.1. So now if we calculate the values, we get the area as 44 meters square. So this is the total surface area. It's been given that the tent is built using a canvas, and per meter square the cost is 500. The cost per meter square is 500 rupees per meter square. So now how many meter square area of canvas do I need? I need 44. So therefore the total cost would be 500 into 44, which is going to be equal to rupees 22,000. So if I'm using a canvas of cost 500 rupees per meter square, then the total cost would be rupees 22,000. Next, problem 8. From a solid cylinder of height 2.4 centimeters, so you have a solid cylinder of height 2.4 centimeters, and then there is a diameter of 1.4 centimeters, right? So now I can write the radius, which is 0.7 centimeters automatically. And what is being done? A cavity of the same height and the same diameter is hollowed out. Alright? So there's a cavity which is being created in the form of a cone of the same radius. So there's a cone. So you have a cylinder. So a cone, a cavity has been created in the form of a cone. So therefore I also need to find the area of the cone. So what is the radius of the cone? The radius of the cone is 0.7 centimeters. I need to find the slant height, whereas the height is 2.4. So I need to find L here. So what is L? So this again forms a right angle triangle. I need to find L. H is 2.4, that is the height is 2.4, and this distance is 0.7. So L is root of 2.4 square plus 0.7 square. So that gives me root of 6.25, which is nothing but 2.5 centimeters. So now I need to find, so what do I need to find? I need to find the total surface area. The total surface area is the surface area of the cone cavity plus the curved surface area of the cylinder, and then I also have a base here which I need to find, isn't it? So I also need to find the area of the cylinder base. Cylinder base. Now why do I need to find the area of the cylinder base? Read the problem. It says that from a solid cylinder. So the cylinder is solid, so therefore this side is covered, the base is covered. So the surface area of the cone cavity, so this is pi rl plus, so it's going to be 2 pi rh plus the area is nothing but pi r square. So this is a circle of area pi r square. So I can take pi r common, so it gives L plus, so if I take pi r common, I get 2h plus r. So I have 22 by 7 into r is 0.7 into, what is this value L? So L, what we have calculated, is 2.5 plus h is 2.4. 2 into 2.4 is 4.8 plus r is 0.7. So what is the total surface area? We get this as 17.6 centimeters square. So problem 9, a wood article is made by scooping out a hemisphere from each side of a solid cylinder. So this is a solid cylinder here, and a hemisphere on each side is scooped out. So this is a wooden article here. So we need to find the total surface area. So what is the total surface area? The total surface area is the curved surface area of the cylinder, isn't it? So I have the curved surface area of the cylinder plus the curved surface area of the hemisphere and the curved surface area of this hemisphere. So therefore, the total surface area is the curved surface area of cylinder plus 2 times the curved surface area of the hemisphere. Now what is the radius? The radius is equal to, here r is 3.5 centimeters given, and then h is 10 centimeters. So that is what has been given here. So therefore I have 2 pi into RH plus 2 into 2 pi r square. Alright, so I have 2 pi r, which is common, so which is h plus r, into 2, right? So I get 2 into 22 by 7 into, the radius is 3.5 and the height is 10 plus 2 into r, so 2 into 3.5. Okay, so this is 3.5 into 2, which is 7, 7 plus 10 is 17, into these values I get 374 centimeters square. So this is the total surface area of this figure or the wooden article which is being made by scooping hemispheres on both the sides of a solid cylinder. So we have gone through all the problems given in the first exercise where we had to find the surface area of various articles of different shapes and sizes. So in the next video segment we should go through some of the examples where we need to find the volume. So here we only had to find the surface area, but in most of the cases we also may have to find the volume. So how do we do that? And we'll also be taking shapes and sizes which are a bit more complicated. So here most of the figures were quite simple. So there were combinations of either a cone or a cylinder or a cuboid, etc., etc. But we shall take figures which are a bit more complicated. We shall go through the exercise problems and then also solve the remaining exercises. So make sure that you do like, share and subscribe, and also click on the, so you can join the Telegram group so that you get all the updates of 10th mathematics, all the lecture videos of 10th mathematics, and thanks for watching.